So good evening, everyone. Thank you for joining here, those people here in person at the UIC Student Center East, and also for those that are joining online. My name is Alvin Chin. I am the chair for the ACM Chicago chapter. I'm also at the UIC Business School, so I'm a visiting clinical assistant professor at the Department of Information and Decision Sciences. And also, another hat that I wear is also I am the advisory chair for IEEE Chicago and the chair for IEEE Chicago Computer Society chapter. So I wear many hats okay. So tonight we are very pleased to have Patrick, how do you pronounce something? Boueri. So he's a director of data science at Indeed, and I'm sure everybody here knows what Indeed is, right? So I don't need to mention about that. So he will be talking about IntentC, which is an experimental compiler of intent. Okay. All right. I just want to do a plug here. So at UIC, we also have an ACM student chapter. So this is their slide. They do like a trivia night, a LAN party, and also some professional speakers. And I believe they're trying to organize something where it is to kind of stump the professors, like in some type using like computer science kind of trivia or so, because I know I got invited to one. So. And the IEEE Computer Society Chicago chapter. So I also serve the chair too as this one. Our vice chair is Rajarshi. Our treasurer is John Waltz. Secretary is Dan Waterloo. And we have our young professionals chair, Narendra Venkatasan. And again, here is our handles on social media, on Facebook, on LinkedIn, and on X too as well. So we do a lot of stuff, ACM Chicago, together with IEEE Computer Society, because we have similar topics, right? We're computer, professional chapters. So, why not we do things together? So definitely special thanks to also the IDS department. They're the ones that helped to book this room that you're in here today. So thank you for them for doing that. And then of course, the rest of the ACM UIC student chapter, UIC IEEE student branch, and also IEEE Chicago section. Okay, and the reason why you're all here today is obviously not to listen to me speak. So we have Patrick Boueri, Director of Data Science from Indeed, and he will give a talk about an experimental compiler of intent. So after the talk or so, if you have any particular questions, think about those questions, jot them down. And then you can post them in the chat. We'll take it from online and also from in person as well. So think about any particular questions that you have for Patrick. So without further ado, I will introduce to Patrick.
Well, thank you everyone for coming. I really appreciate it. As Alvin graciously introduced me, my name is Patrick. I work at Indeed. My day job isn't really software engineering per se. It's more focused on data science and experiments and marketplace stuff, but I've been enamored and terrified by the events of the past 2 or 3 years about how our field has been changing. And so I like probably many of you have been grappling with it. ACM is a wonderful place to share this. I don't know if everyone knows this. Greg was sharing this with me. The ACM Chicago chapter is one of the longest continuously operated chapters in the world. ACM is a foundational society to computing. Computing goes back a long way more than 100 years. But in particular for this talk, this field, I feel a little bit of connection to history because Stuart Feldman, who was a ACM president, created Make. And Make is a foundational piece of software at Bell Labs in the 1970s. And Make really laid the foundation to build software over the coming 50 years. And, it feels like we're at an inflection point where something will change. What that change will be, only time can tell. But this is my attempt at trying to paint something, a vague, blurry shape of what I think it may be. Obviously, I don't know the answer or the truth, and I would love to hear what you guys think. I think we will only figure this out together. So this is really meant to be a collaborative talk at the end, so please feel free to pepper me with your worst or best questions. I have a mentor who called it the rudest questions. Pepper me with your rudest questions. It's great. Okay, so IntentC is an experimental compiler of intent. That's a mouthful. It's hard to understand. I will certainly try and this is the most concise way I could express what I was thinking. It was my best attempt at reflecting my intent of this talk. Okay. So everyone's kind of feeling some kind of way. Anthropic did this weird and wonderful study where they interviewed a lot of their users, 81,000 people from around the world, and they were interviewed by Claude itself, like by the LLM. And the LLM did the analysis, and the LLM represented the survey backwards. This is somewhat of a novel thing where LLMs are now a media of communication. They're the way that we communicate, and they bring their own biases and their own wonders and weirdness to how we communicate. And we're going to have to learn how to use these things over time, right? It feels like, ChatGPT, who cares anymore? That was 3 years ago. And like the pace of progress is like blazing, but really this is a societal change that will take, decades to really make. I really like this quote. The good news is that everyone can use AI. The bad news is that everyone can use AI, right? Kind of think that captures the duality of what we're all experiencing these days. In particular for software engineering, the vibes are in control. I'm sure a lot of us are allergic to this idea of vibe engineering. It's kind of like a Rorschach test for how you approach software engineering. So vibe coding is the word of the year from the Collins Dictionary. You can see our helpful person over here saying run the app. That's essentially how you vibe code. You just tell it what to do. You don't even specify anything, and you just hope for the best. And it's been a real expander of who can code and how they code. Software engineering, I'm sure the members of ACM know this, is a discipline. When you make mistakes, they have real world impact. We don't really have professional standards like other engineering disciplines do. And so vibe coding is this weird extension of the practice of engineering that feels almost like we're off the cliff, right? But also, if you've ever done it, it's really fun. So I also think that a lot of this stuff is frying our brains. This is an HBR article that talks about people that are, and I've seen this firsthand in my company as well as in myself, that you feel like the distance between what you want and what the computer can do is razor thin, right? You say something and it does it. It's crazy. And not only can you say one thing, you can make many things happen at one time. You can run many agents at one time. And so there's this really weird, I'm almost going to frame it like psychosis that's happening, where people are tied to their computers, where they feel this like urgency that they're going to be left behind, that there's this wonderful something on the other end if they just magically write down the right words, right? And so we're keeping these threads open in our brain all the time, and it's really causing some intentional issues, I think. It's really burning people out is maybe the right term to use. And so this paper goes through that, and they actually do surveys, and they show that, like, yes, actually people do feel burnt out, and there needs to be some sustainable pace, right? Like these things are rocket ships, but we can't move our brains that fast. So how do we really work with them? And so the IEEE defines software engineering as the application of systematic, disciplined, and quantifiable approach to the development, operation, and maintenance of software. I just want to say vibes are the total opposite of this. There's no measurement. It's not disciplined. There's no systematic approach to it. Maintenance, like who knows? Operation, who knows? Development, can you even call it development? And so, but code's being produced and applications are being made. And so it feels like what we had as fundamental truths maybe 5 years ago are now being questioned, right? People are doing this because they are, I don't know if anyone's ever read The Innovator's Dilemma. There's this idea that you can have this new product that does something totally different, right? It may seem totally so hardware disks is what he studies. And at the time, disks are really important for mainframes. And so they're making disks bigger and bigger and bigger because they want storage, right? And they never see the personal computer revolution coming. And so someone that makes a smaller disk and a smaller form factor that can meet the storage requirements of the personal computer actually wins out. And eventually mainframes adopt it, right? And so you're competing on these different dimensions than you have historically. And it feels like there's something true here where the demand for vibe coding or whatever is so high that we need to unlock that while also keeping our systematic principles. Like, how do we get to the point where we have enough rigor and enough confidence in what we produce while also embracing this new speed and this great democratizer of engineering, right? And so the idea that this is how we're expressing it is someone has this intent. This intent is this like this thing. It's like a manifest of my will. It's like, what do I want to do, right? That's what I'm calling intent. And it's very fuzzy. I don't really know what it is. I have to see it. I have to iterate on it. I have to refine it. But I'm telling the computer to do it. Then there's this like weird translation layer by these magical LLM things that then generate high-level languages that then get compiled all the way to bytecode, right? And by doing this, the speed is way up, who can code is way up, and the toil is way down, right? There's these new dimensions that are really attractive, right? It's important to not discount these benefits, right? But I'm sure we all know that there's some problems with it, right? A couple things that I could just do from memory. Again, this is not like a rigorous treatment of the issues here. I would love to see more development of this and a better language for describing this. But one thing is that when you talk to your agent, you can think of it as a function that has randomness in it that takes as input both your prompt, but also the state of your machine at that time, the state of the model at that time. There's randomness in the model, there's randomness in the time of day and the load and all this other stuff. So it's not independent, it's not a hermetic thing, right? Whereas like when you compile C++, that is all the full specification of the bytecode, right? You don't need something necessarily extra. Of course, there are like compiler flags and things like that, but it's not like you need to check the position of the sun to understand what will be produced. Another thing is this idea of under-specification or over-specification. We are very bad at describing what we want, and so you can way over-specify or way under-specify what you want, right? This leads to like uncontrolled variance. You don't really know what will happen, but we're treating these like lottery machines where you just pull it, and if it pops out the right thing that's like, if you squint, it's right, then great. You don't have to understand if there's a lot of variance there. And you're losing a lot of context. So a lot of people do this stuff in conversation. I'll kind of show you how coding agents work if you haven't seen them. But it's a lot of conversation. It gets lost, right? It's not versioned in Git the way you would version code, right? So this all boils down to me is, can you reproduce it? When you're producing code with whatever process you used, can you reproduce something that looks like the code that you just made, right? So of course, this is not a novel observation. A lot of people have been doing things around this. So one very popular idea is this thing called spec-driven development. Amazon's created an IDE around it. There's name your favorite framework around it. And the way it goes like this is you get a feature that you want to implement. You detail a prompt. That prompt is then written out as a spec, and then a separate agent goes and implements it, right? So you have the spec prior to the implementation. That generates a code diff. Frequently, you'll tweak it at the end. You'll say like, okay, the spec is great, but actually, this method looks weird, and I want this naming convention, and also, oh, you shouldn't do it that way because, that caused a crash in the past, some memory leaks, please change that. And so you'll have a conversation that will kind of tweak it, that's not captured in the spec, and then eventually you get to a code diff that you're happy with, you submit it for a review, gets committed, and then you do that again, right? And so it's this like kind of isolated to a single feature. It imposes some rigor, but maybe not enough to reproduce things. It's a step in the right direction, right? So we have a reproducibility crisis, and I think we have a failure to communicate with our agents. We don't know how to talk to them yet, and so we're learning it, right, as a society at large, and it's kind of Darwinian, and we'll figure out kind of what bubbles to the top over time. So IntentC. So here's my idea how to solve it, okay? And I actually don't think it solves it 100%. I'm going to show my cards already. I think it has some good ideas, but I think there are some shortcomings too that I'd like to talk to you about. So the idea is like, it's not magic. It's not anything special. It's you insert a new language right before it, whatever you compile to, Python, JavaScript, Rust, whatever it is. That's called the intent DAG, right? DAG is a directed acyclical graph. It's like if you're thinking of make is a DAG that specifies compile this file, then compile this file and generate these targets, right? And then you can rebuild everything. And so the idea is just do that, but with some structure around your prompts and your validation, whatever the workflow is within spec-driven development, so that you get something that feels hermetic and reproducible. Okay. And I know this is just a concept, so I'm going to show you concrete stuff. But that's really all it is at the end of the day, is like write it all out. Don't rely on anything ephemeral. You have to go through whatever this layer is to get what you want. And it's maddening to do. So here's what an intent feature looks like in IntentC. And these are things that I think are important. Obviously, like if you were to build your own version, maybe you would have different things. Maybe you'd reflect it differently. Maybe you would define intent in a different way. But here I define this intent feature. An intent feature is a spec like we have. It has references to context, like think like if you're doing a website and you're referencing a logo, it would have a logo, for example, right? And it has a validation file. And a validation file is separate from the spec that's checking, did you generate what you wanted to generate? If not, go back and iterate. And there's some iteration time. And that's it. There's those three components. It's a spec, it's validation, and it's context for the feature. Okay. And it's an atomic build, right? It's all or nothing. So this is like a really important concept in reproducibility. You don't want any like partial builds or any hanging anything. What's important is it's not one-to-one with the module of the generated code, right? So typically when we think of compilers, you're thinking like, okay, here's one file. I'm going to compile this one file, then I'm going to compile this other file. And each file is this logical representation of something in my code base, right? But here, this feature could modify your entire code base. It could be a full refactor, right? But it's a single operation on your code base is kind of the point, right? And so when you take this feature, you build a project out of it. Sorry, I forgot to delete that slide. Intents are wired into a feature DAG. So you have, for example, like your auth module, your database setup, your embeddings. This is for like some hypothetical search product. That's kind of what I've worked on in the past. That builds towards an API, right? And so you have these different features that are composed. They have some dependencies, and then they create this full DAG. The project also has two other files. These were things that I thought were important as well that I found myself doing when I work with these tools. One is a project file that describes the overall intent. It's important to keep the big picture in your mind as you do things. And then implementation. So the idea here is that whatever language you choose or databases you choose or whatever it is are kind of somewhat independent of the intent. They don't need to be, but they can be, right? And so with an implementation file, you can take the same intent, and if it's truly reproducible, you can generate the same program in Rust, as well as C++, as well as Python, as well as JavaScript. Maybe you're relying on certain language features that aren't broadly shared. But the idea is that if you do a really good job, it actually doesn't matter what you're compiling to, right? So for example, Clang, the compiler for Swift or whatever, can compile to both Intel as well as to Mac Silicon, right? Compilers have LLVM is a storied project within Illinois computing history, and its fundamental revolution was it created a middle language that could compile to any target, right? And it is the foundation of modern compilers. And the idea here is like if really the high level language doesn't matter anymore, then you should be able to compile to different targets without thinking about it, right? Again, easier said than done for sure. So this is kind of what it looks like. I'm going to walk you through a very simple example. So you would have a project. It's files on disk. I made up some file ending that I thought was cute called .ic and .icb. So the idea is that you would have your intent folder, and that has your project and your implementation specs, as well as like whatever module and features you want. And these are all laid out. And then you have your source. and your source is separate from your intent that is generated, right? And can be regenerated and regenerated and regenerated. And then you also have some hidden folder that tracks configuration and state and things like that, right? And so at its core, it's literally just a Python CLI program that has a bunch of options and commands in it that do this building for you. It's essentially orchestrating coding agents like Codex or Claude, or there's open code is a really good one where if you don't like sending your data to these third parties, you can run everything locally. But essentially, like this is what it's doing, right? And it kind of looks like this to give you a visual idea. It builds each feature, it validates each feature. Once it's done, it's great. Let's move on to the next. And it just sequentially builds your code base like that, right? And it tracks the state. It has logs of every build. It commits each step in Git. So like auth is an independent commit from DB, that type of stuff. And it allows someone to build incrementally from scratch. There are some other workflows. Bootstrapping these things is kind of a pain, I found. So init creates a new project. You can talk to an agent. It'll generate files for you. It has like an idea how to do that. Plan is if you want to create a net new feature. Validate is if you just want to run validations without any features. Status and diff is what happened. And then compare is this really elusive concept for me of comparing two code bases. So imagine you generated the same intent file into two targets. How do you know those targets are equivalent or within some degree of tolerance? Totally unsolved, probably never going to be solved. But it's this idea of like, can we create heuristics to get to the point where you know that when you generated something yesterday and today, they are the same, right? That's like kind of the core thing, right? Okay, so I want to introduce two concepts for you, and then I'm going to show you the live demo. So the first one is this idea of two ways to make software. Longest time, well, actually, I think we have to rethink about what it means to make software. Hands-on keyboard, everyone was doing building up until 2 years ago, right? So building is you do brick by brick, you write the module yourself. Maybe you're using some generated code or whatever, but like essentially you are in command of building up the program brick by brick, right? And there you're spending so much attention on every detail that you have the full picture of the project in your head, right? But there's this other way that you can build software now that's kind of like vibe coding. It's called shaping, okay? And what I want you to think about is like a Gaussian process, okay? So Gaussian process is this idea of you can have many different functions that then collapse to some, you eliminate some of them as you observe more data or you add more constraints, okay? And so the idea of shaping on the right is that you would define intent files or something like constraints on the program such that it creates the shape of program that you want. But notice that there's still blue shaded regions. That's still variance. There's still variance in the program. If you were really trying to make something that is carbon copied, yeah, you might as well just write code, right? At the end of the day. But if you're trying to shape a program where you don't really care about certain details and you're willing to accept some tolerances, which is a very engineering thing to do, then you can do far less work, right? Here you have 6 points versus however many bricks and get the same program functionally, right? And so the idea is that you can shape programs too. And historically, we've done this by communicating to other people who then do the hand-on keyboard. And now we can communicate to our computer that then does it. It just happens that the computer can do it so fast that we can't absorb all the information. The higher up you go in an organization, you will never read every line of code. You lose context and you trust that the people that are writing the code understand what they're doing and that there's some level of discipline and validation and things to build up the programs that you care about, right? So organizations, when you think about them, are essentially like shaping programs through the organizational structure. That there's this thing called Conway's Law. If you haven't worked in the industry, it's the force where you're always like, why is anyone doing anything? And it's Conway's Law. It's essentially you create programs based on your organizational structure, not the other way around, right? And so if you have a team that's focused on the front end and a team that's focused on the back end, your architecture will be front end and back end totally separate with distinct design decisions, right? Because you have high communication in there and low communication between them. And so organizations are fundamentally shaping software, right? Um, and so we have been doing this, but we've been doing it in a mediated and trusting way, and we've been bringing common sense to it. Okay. Another thing I want to bring is this idea of specification spectrum, which is also something that we all know. So here's the spectrum for making dinner. I like to make bolognese, and so here you can think of like roulette would be like make me dinner. If anyone's ever seen Random Sort, it's like kind of like that, right? Where it's just like I hope it's right. I don't know. Eventually, I'll get to bolognese. And then all the way on the other side, it's like here's exactly how much you have to do for every single step. And it's a full description, right? And you could take this, to the nth degree where you're like, the temperature on the pan at this point in time should be this, right? Those types of specifications, you can go arbitrarily specific, right? But at some point, you're spending more effort defining the spec than is useful. You're wasting time. And maybe you want some variance in your bolognese. You don't want to eat the same thing over and over every day. And so, maybe there's some sweet spot in here that represents your intent, but leaves sufficient room for surprise or creativity and also preserves your attention, right? Writing out a spec that does that temperature at every point would be laborious. It would be an awful use of your time. You got stuff to do. So there's this specification spectrum that we have to think about when we're doing this type of work. All right, so here's my demo time. This is where you get to see the program itself. So just to give you a feel for what we're going to be doing, we're building a shape canvas. Okay, a shape canvas is an HTML application that shows you a couple shapes. Not very exciting, but there are two. It's something that I could run in the time that we have. There's two implementations, one in JavaScript and one in Python. Okay, so I'm going to kick off both, and then I'm going to talk about. All right, so here we have. Cool. So this is the program running. You can see like the agent here is giving you feedback about like, hey, here's what I'm doing. You got logs. You can see that there are 6 targets that you're about to build. And it's running in a folder that was empty except for these intent files. Okay. And then to give you a feel for each one, so let's talk about like blue square. So blue square is place a blue square field to the right of the red circle. The square should be positioned in the bottom right quadrant, blah, 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 blah. Is this overspecified or underspecified? Depends on your intent, right? You can see that there's some front matter here that defines the dependency graph. So here it depends on red circle. Don't do this until red circle because blue square needs to go to the right of red circle, right? And then there's a validation here. And this was fun because I was trying to come up with like, what's a good language for expressing validations? And if you don't know what the code that you're going to generate is, it's kind of hard to say like, hey, does this file exist? Or run this command? And so you eventually wind up with like an agent validator, which is kind of what the fancy term for it is LLM is judge or something like that. But essentially at the end of the day, it's a prompt that says, hey, does this do what we want it to? Right? And you can add arbitrarily many. If one fails, the build will fail and it will reiterate or it will stop. And so this is how you can check your work. Again, there's variance here. I find that these, especially like this year, these agents have been able to follow instructions extremely well. So if you don't know anything about how they train these things, they do train on everything everyone said on the internet forever. But then they do this thing called post-training. Post-training is essentially they are refining the output of these models based on task following. They have these crazy suites of coding or reasoning problems that they unfurl, they compute them all, and they use reinforcement learning techniques to steer these models to produce the right thing. So they become very, very good at instruction following. And that is like the name of the game. So reasoning models and all this kind of stuff is like really the post-training thing is what's unlocked this stuff, kind of saturated the internet text. So, okay, so we're running still. Here you can see like it'll take some time. So I think we're on like target 4 over here, and we're on target 4 over here. So I want to give you just like a real quick demo of what you can do. So for example, here's a status of a built thing. So you have each target, you have when it was built, you have the generation ID of when it was built, right? Things like that. You can arbitrarily inspect them. So you can say like, hey, I want a diff of the builder. Obviously, it's not very pretty, but it'll show you everything that it generated within that step. So if you ever want to inspect like a particular thing, they also have logs and the validation, things like that. It's all stored in the SQLite database somewhere. But to give you the sense of like observability, reproducibility, that type of thing, right? It's not just like we don't know what happened when this thing was generated. You can clear out a build and then rebuild it from a particular step or altogether, right? So there's this idea of rebuilding. All right, so we are almost done. And then what I'm going to do is I'm going to be opening up both of these builds. Again, one is in JavaScript and one is in Python. And we're going to inspect them and see what they look like. Okay. What else can I share while that's happening? I don't know. Anyone have a question? Probably have like 1 more minute, 30 seconds. Yeah, what's up? Ask me one right now, and then we can.
Uh, So looking at this, the biggest question that jumps out of my mind is, what is the imagined utility for this sort of project? Because, for example, in the Bolognese example, for making Bolognese multiple times, you might want slight variations.
Mhm.
It's been my experience when doing software development that the exact opposite. In fact, the amount of hours that people pour into avoiding the slight variations is exceedingly high. That most of the work is managing the complexity of the thing that you're building such that it is consistent over time.
Sure.
Because anything not expressed in your spec, say commercial behavior that other customers rely on, if you simply one-shot the thing from the beginning, you're going to break absolutely everything that relies.
Sure. Yeah, okay, so the question was, what's the imagined utility? For Bolognese, maybe you like some variants, but for a very detailed, for an aircraft control system, you actually wouldn't want any variants. You want things to be provable, right? You want them to be actually, and there's like these formal provers that make sense, that make sure there's no bugs in the software because it's so critical, right? And doing this intent type stuff introduces too much variation, it actually would make the project useless, right? So that's the type of question. I think there's this thing called Hiram's Law. Hiram's Law is this idea that with any sufficiently large usage, every bug becomes shallow. The idea is that like your program is exposed through your interfaces, and when you vary something slightly, it actually becomes an issue for someone somewhere if it's used enough, right? My answer to you is that the benefit is speed, and the benefit is this idea of opening up who can describe things, right? And the cost of it is this reproducibility, right? This cost of it is the variance of the generated program. And so the question is, what applications can tolerate some variance in some aspects to get this speed? That's essentially, and I can tell you from industry, people are doing this all the time, right? We are tolerating. And again, the source doesn't go away. The source still exists. You can use that to like compare and diff and things like that. But we are tolerating a lot of variance because the speed benefit is so high. Creating programs, especially for economic purposes, has a cost. And these things have dramatically reduced the cost of generating programs. But we're accepting too much risk, right? So the question is like, where do you balance this risk versus cost pendulum? And in some projects, this may make sense. It may make sense nowhere, but it is trying to explore this concept of is there a middle point between these two extremes? All right, our thing ran. So here we have a source, we have a README, and we have a start. So I'm going to open this one up, allow. Here we have our canvas. This is in JavaScript. You have a top left triangle, bottom left circle, and square. And you can see it's served through, it was served through, I think, Node or something like that. And then here we have another one. This is the Python one. Oh, sorry, give me 1 second. And here it looks a little different, right? So you have the Python one and, sorry, I was using the wrong command. And the node one. So you see that they're a little different, right? Circles, bigger, square, there's variance, right? They're in different languages. You got the labels on the top left, those were not specified. And so you wind up with something different. But if all you care about is communicating the concept or something of, circle, triangle, square, definitely comes through, right? And so was this easier than just doing it explicitly? Probably not, but it's meant to illustrate the idea, okay? All right, I'm gonna go back to that was the demo. I did some experiments. Nothing grinds my gears more than someone doing like a blog post and it's like, I generated this code base and they one-shot it and that was the end of it. There's no reproducibility or anything like that. All the labs do this. The labs are the term that we use for the people that make these coding agents like the LLMs and stuff. And they say like, hey, look what I did. It was one time. And like, okay, but that's like a lottery machine. You pulled the thing and you got 777, good job. But how many times did you pull the machine and what did you do? And can you do it again? And does it matter? And I don't know. So one thing that I did is it was really hard to actually come up with a project that would be useful or fun to talk through, but I realized I have probably 5 more minutes. I did a 2D zoo builder game, right, with increasing intent levels. So it's this idea of the specification spectrum. The intent files get more and more detailed over time, almost to the point where like level 5 is code, essentially, okay? And then I ran them each 5 times to see the variance and what they look like and things like that. So here's some specification. So the more detailed, the longer the build. You can get arbitrarily complex. You can get a lot of lines, right? 22 versus 5,841, right? Like there's a huge spectrum of what you can specify. To be clear, I didn't write these files. Again, you use these agents to generate things and blah, blah, blah. But it gives you something interesting, right? And so you can say like, level 1 is just make the zoo, right? Let's just make the app, run the app. This one's like, make a zoo, but here's some little details. Here's 3 things I care about. And then here's like 13 things I care about. And it gets deeper as you go, okay? So here's an interesting way to think about it. The more detailed the spec has more code, right? In this example, so one way to think about this is the ratio of spec to the ratio of code, right? And lines of code we all know is a very poor measure of complexity or information. There's a lot of boilerplate, but bear with me, level 1, you have, for every line of spec, you have 30 lines of code. And for level 5, it's like 1-to-1, right? So it's trying to explore this space, essentially. And you can see here, this is the grid of the generated thing. So top one, you're not expected to read anything, but the top one is the least specificity and the bottom one is the most specificity. The gray boxes are because it failed. And you can see that you have a lot of variation in the green zoo area. There's like a path over here in level 1. There's a lot of creative liberty, right? The menu bars are different. And then you start to have a little bit more consistency, but not so much. Then you start to have a little bit more. Then you have some more. And then finally, they're basically carbon copies, right? So the idea is like you can get arbitrarily specific where these things are reproducible. But then why are you doing it at the end of the day, right? And so there's like some sweet spot here. You can measure. So I was trying to come up with ways to measure code variance, 2 code bases, how similar, how different they are. Very difficult to do. You can do AST parsing and things like that. But in this case, what I did was I used normalized compression distance. So it turns out that if you like use a zip program or something like that, they're very, very efficient at representing how many similar tokens or terms there are versus how many different ones there are. Especially if you sort the files and sort the names and things like that, you can get maybe a good approximation of how close the code is. And so you do get a declining spectrum of distance, right? So the more specific, the less variance there is. You can also get, just count the function names, for example. What are the functions? What's the set of function names and overlap them? And you get way less variance the more detailed you go, right? So you get a high variance over here, very low variance over here in terms of function names. So you can kind of see there's a phase change where we start to describe the code that's implemented in spec 4, where it starts to say like, hey, write a function called this that does this, right? Whereas in spec 3, it's not that, right? And so there's this phase transition of where you start putting code into these things as a way to improve reproducibility. So the good is you can make builds more reproducible. You can start to measure variance. Intents start to look like code, at which point, like, what are you doing? Reproducibility comes at the cost that may not be worth it, but there may be a sweet spot for particular programs where it is worth it, right? So there are challenges with doing this. Coming up with a good task is hard. Games are a good one, but I don't know if mine was that fun. Measuring code differences is hard. Variance is very high. So if you have a good experiment you want to run, let me know. I'm happy to burn the tokens to do it. I really want to explore this idea more because I think it's fundamental to this idea of reproducibility. As a side curiosity, I thought IntentC is itself a program. It's specified in intents. This is my third time writing it. Again, writing it is working with agents to write it. And so I wanted to see if I could self-compile, right? So this is an idea in compiler development where you do this thing called bootstrapping, where you get to a point of maturity where your compiler can compile itself. It's kind of a weird way to think about compilers. But essentially, you write it in one language to the point where you can self-compile, right? And this program is self-compiled. I'm terrified of it because the variance is so high that I don't know if I'll break it if I do it again. But it's fun to do this task because these agents are very good at working towards a goal if it's measurable. And so you can define a self-compilation goal, and it will churn through it, updating the specs of the code to the point where it becomes self-compilable. Right? But then it gets arbitrarily detailed. So then you're like, hey, raise the level of abstraction and things like that. And so I did this 3 times to get to a point where I feel happy with it. I'm still not totally happy with it, but it was kind of a fun side exercise to see if this thing can, do something fun. All right, so future directions, and then we'll take time for questions. All right, so why I think I could be all wrong about this is it may solve the wrong problem. Maybe there's no language above high-level programming languages. Maybe that's not a useful thing to create. Maybe reproducing code from scratch doesn't really matter. What matters is the efficient production of code. And so this idea of oh, you need the code at state X to generate new code doesn't really, great, that's fine. It's a new way of developing software. Another thing is it sucks all the joy out of writing code. It's no fun to write specs. It's maybe for some people they enjoy it. It's no fun for me. There's no well-specified language. So writing Markdown is just arbitrary natural language. And it applies to the past to the future. Maybe it's taking this idea of code bases and applying it to something new. When a lot of people are talking about ephemeral programs that come up on the fly based on need and these various ideas that maybe are different than trying to retrofit, say, make onto the new world. I think trends that may help it become real is speed. There are some unreal LLM speed benchmarks that people are producing where they bake models into silicon, and they're getting to the point where code generation is instantaneous, right? And so if speed is no problem, then you can stay. One of the problems with compilers is if they take a long time, you kick it and then you have to run off and you lose context. These things get really fast. You can stay in the event loop and you can actually develop things well. Each model gets better at following things and probably has better taste and less variance and things like that. And a lot of people are starting to focus on verification. So Terence Tao, who's a famous mathematician, there's this cool programming language called Lean. Essentially what it does is it proof checks while you compile, and mathematicians are starting to use it, which is really cool. And he says, these things can generate proofs up to wazoo, but now the problem is verifying them. Can we understand and check these things to the point where we understand what they're doing, right? And so it's not theorem generation, it's theorem understanding. That's the problem. And so I think with code, it's the same thing. It's you're generating so much code, how do you understand what's happening in here? And harkening back to that Anthropic survey, LLMs are going to be part of the distillation and getting it to where our small brains can understand what is represented here. I do think of this as a real product. Potentially. I think there's a lot of work to do to make it a real product, but if it were a product, so imagine you're trying to build the new compiler of the future, the new Bazel or something like that. There's a lot of things that we would layer in. I think the first one is thinking in tolerances, so really nailing down this like idea of variance in code generation, and then trying to come up with specs that say like this can have high variance and this can have low variance. I think that cloud builds are important. I think like formal API contracts are really important. So like C has this concept of ABI, which is making sure that like, hey, a program looks the same from the outside. You could come up with something similar. I think there's a lot of things that could do if this was a real product. I think the most exciting thing is this idea of like network effects. So typically when you write code over here, you can't really port it over. You can, but this idea of like verification, you could start really learning from other code bases of how to verify a particular feature or something like that. And so the more people that do it, maybe the better we are at expressing ourselves. So that's it. Thank you so much for listening to talk. I really appreciate it. I'm happy to take any questions.
Thank you. Okay, great. So maybe we'll go ahead and start with some questions here in person, and then Payam, you can go ahead and get some questions from the chat.
So yeah, over to that.
Yeah, so I know it's mainly focused on getting the one-shot reproducibility, but like if you do want to narrow down the spec of it, actually working with it, would you want to be able to add more nodes for the DAG or just?
Yeah. So the question is like, hey, instead of just one-shotting everything, can you do things incrementally, right? And the answer is yes, for sure. So that's spec-driven development at the end of the day, right? Is this idea of like getting something. So I'm working on a new feature. Actually, I didn't put them in the slides. But it's essentially like, hey, what am I doing? I have an existing product and I want to add a new feature. You're just adding a new node in the DAG. It's incremental. It's not a full rebuild. The full rebuild can be asynchronous. The full rebuild can be something else. You're just working on this one thing where it's easy to delete and rebuild, and it's much faster, right? And I think this fundamental atomic operation is like people do today. If you listen to the product manager of Codex, for example, the OpenAI coding agent, they talk about the way they one-shot, and they do this all internally, is they generate 3 variants at once and pick the one they like. If they don't like it, they one-shot it again. They don't try and tweak. Right? They really try and be disciplined about the one-shot idea for an incremental feature.
Yeah, kind of similar to that, but just trying to understand if there's some concept of versions, or do you take your various intents before you tweak them? Do you save those off to like a Git repository, or you just work on what you're working on?
No, so everything's in Git and versioned, and so here, let me maybe illustrate the point more cleanly. Sorry, so if you look at the Git log, you have each commit as a generation and hey, I built the green triangle or something like that. If that makes sense. So you're versioning as you go. And then say you're like, oh, shoot, I didn't want to build the guide. I want to tweak it. You would roll back and then rebuild it, right? So there's no need to reinvent, state management for files and diffing and things like that. Although I do think Git is going to change. Like we will have a new VCS at some point, I think, because it's less intuitive to do it this way versus other ways for these agents. But yeah, you would have state managed that way, for sure.
So I've been using maybe not these same techniques, but I've certainly been dabbling with AI tools, and I think it's great. Where you can, it seems like the better you can describe what you want in English, it seems like you'll get a better result from that. But what I think if you have this, it produces a system, program, whatever, and now you need to change parts of it. How well are you aware of like where to change, and how can you break that down, saying like, okay, this is fine, but this section needs to be changed for a different purpose. And it seems like what is missing from this development, not your development, but a lot of it is, can you overall just put a form saying this is the form of the application?
Represent the application in some way.
Right. Much as like you would, in easy cases, what's the form of playing this game, or what's the form of a book or a movie? But you should be able to apply that to a normal run-of-the-mill application as well.
Yeah, I think we're cobbling things like that together with skill. There's this concept of skills, which is like these ways to describe how to do certain things that can be loaded in at certain times. I think a lot about what you're talking about is refactoring or incremental addition. So I find these tools are actually pretty good at navigating code bases. What they're not really good about is following the same patterns. Unless you tell them what the pattern is, they won't infer the pattern from the code base because they won't have a ton of examples, and maybe you know it in your head. So as long as you describe that pattern, think like in object-oriented programs, we have things like visitor pattern, whatever. Like there are certain ways that people craft code that are match how they want to do it that are not well represented. And these things are trained on all code everywhere. And so they might pick the wrong thing that's most expedient or something. And so companies are starting to do this thing where they develop internal style guidelines for these agents, right? Where they say like, hey, this is how we develop programs. And before those were like guides for people to read, and now they are enforced through the agents. And so there is some rule following that I think will get better as more people use this, because you're taking the person out of it in terms of interpretation. You're putting maybe a machine that can interpret it better. But to your point about like refactoring, like here's the form of the application, and I always want, I want like a what is it, like the 4-layer app or whatever. I want like the database layer separate from the business logic. You can, if you do the work up front to write that out, then it will follow it typically. I do like this idea of absorbing or distilling as this idea of refactoring, because remember, these are not single files. They are features that could operate on the whole code base. So imagine you forgot to add logs, and you add a feature at the end that says, hey, add logs, goes through and adds logs everywhere. Instead of doing that, you could make it all the way at the top of the project guideline, right? So you could remove that feature and put it in the beginning, and then it would regenerate the code with logs in mind, right? And maybe do a better job of it, maybe not. Again, the variance is very high on these things, but it does mean that you work with software in a very different way than you would ordinarily.
Okay, let's take some maybe question online, and then we'll go back to in person. Payam,
Yes.
is there any questions from online?
Yeah, thank you, Patrick, for the talk. I really appreciated how you framed like at this moment in software, as both it's exciting and also it's little destabilizing, and how IntentC tries to bring more structure and trust into in the development. I also thought that the idea of a spectrum between under specification and over specification was really helpful to think about where these workflows may be headed. I personally have 2 questions. And then if there's any question in the chat, I ask one of them, and then if there, I can ask the other one later. My first question is this: IntentC already seems somewhat agentic. Do you see it's basically evolving into a fuller multi-agent workflow, or do you think the spec layer needs to stay mostly human, for the system to remain trustworthy?
I think the authoring of the intents is a collaboration, not purely human. And the core driver of this thing is a loop that essentially prompts agents and spins them off. And those agents can also, depending on how they're set up, spawn other agents. So there's like an arbitrarily nested tree of this development, right? Again, think of an organization, right? Think of it like a company. Like you express some intent. We want to build this product, and then it gets broken down into individual discrete actors. So I think it is agentic. I think the way to mature this thing is to really track state better and to compare generations better and really focus on this idea of the iteration, like make it pleasant to use. I'm a real believer in like software. If it sucks to use, no one will use it, right? Like the ergonomics really matter, and the ergonomics on this thing are fun to demo, really not fun to do. I was trying to build a separate project with it, and it is like kind of like pulling teeth. I'm going to keep trying it. I think it's either too early or the bad idea. But I don't know, there's something here. So thanks for the question, Payam.
Thank you.
Thank you, Payam, for the invitation. I really appreciate it.
Thank you. All the pleasures are us.
Yeah. Any other questions online, Payam, or?
I have one more question. So,
Okay.
in your talk, basically you suggested there may be a sweet spot in how much a specification to provide.
Mm-hmm.
Is that based mainly on visually reading the plots, or did you have a more formal way to
I don't know.
identify that cutoff?
I really don't know. I think the more we do this, the better we'll be at it. I know what I do internally is I start speed reading these things and trying to pattern match. So what I'll do is I'll say like, so I built an application recently. I used an API key and I wanted to use OAuth. I said, hey, implement OAuth. Here's the things that I want to care about. OAuth is this like authentication workflow that uses a third party to verify and gives you a token that expires and things like that, as opposed to like full user access. And you can kind of tweak it. You say you give it that initial prompts. One way that I make this more convenient is I say I use like voice to text, and then it will record my voice and then write it out. Let's see if I have the right voice to text. I don't know if anyone's ever used Whisper or something like this, but where'd I go? Voice to text. So you can like talk to your computer, which sounds insane, but your words per minute is way higher, right? And like you can ramble a little bit, and you're not like you can be more raw about what you're thinking. And it's all about trying to narrow the barrier between your intent and the machine, right? And so like I find this to be super helpful. So I'll describe a paragraph, it'll go off and come back with a plan. I read through it, I give it like a couple pointers, go back and forth, and then it generates a thing, and then I'll review the PR in GitHub. If you're trying to review everything line by line in GitHub, you won't get the speed benefit that you're looking for. But if you're working for a real production system, you better do it, right? But like if you're doing it on the side, you should you're maybe hamstringing yourself. And so maybe the idea of the future, I was brainstorming with a friend, is a conversational IDE where you talk to it and it shows you just enough information that you can process at a particular time. Like in signal processing, there's this thing called baud rate. Baud rate is how much information you can put through in a particular system. And we have a baud rate for our brains, right? And everyone has different ones, and it varies in time. And so the IDE would try and match that to try and figure out what can I show you exactly to elicit the intent that you're looking for. And it may take one sentence for a very common, well-understood thing, and it may take a multi-day conversation for something that's very obscure, right? And so I don't think it's a one-size-fits-all specification sweet spot.
Awesome. I really like it. I personally know my brain just have one sentence at a time memory.
Right. Yeah, we all do it differently, you know.
Thank you.
Sure.
Okay, so maybe time for one or two more questions before we end. Yeah.
So when I think about coding, I think about the infrastructure as separate from the features that are kind of sitting on top of it. And I'm just kind of wondering if you had like kind of a code base that is like, okay, here's your infrastructure, it's like, you know, setting out like all the patterns and security, all the things that are kind of you know, foundational that maybe you want to like hand code and like put a little more effort into, and then do the IntentC for the features on top of it, where you maybe like you don't like variance isn't as much because that you have that foundation kind of like in place first, and then you can maybe handle like maybe those variants in kind of the features. They don't matter as much if you're testing for the outputs that you care about.
So the question is like, maybe there's two areas of program of a software system: the infrastructure area and the program or code layer. The infrastructure system matters much more and needs less variance and more stability. Think a database. You don't want to regenerate the schema each time. You'd lose data, for example. And then for the other side, like maybe you have some tolerance in what a drop down looks like, for example. I think intent can be, again, there's a spectrum. And so there are concepts of infrastructure as code. There are programs like Flyway or Alembic that allow you to create databases. And so like I don't think it's an either or. I think it's more like the degree of specificity relies on how critical the aspect of it is. And doing this stuff, Markdown is a very flexible format. You can put anything in it. If you're defining a schema of a database, there's no better way to define a schema of a database than the DDL of the database, right? So like just putting that in the text is sufficient, right, for it to use it. And there's no arbitrariness there. That's the schema of the table. And then if you want to change it, then that maybe you rebuild the program, but then you lose state and then you have to migrate it. And so there's difficulties there, but I don't know. I do think for this to be successful, it does need this idea of progressive adoption. You don't need all or nothing. So I don't know how that would look, but it's a good idea.
Okay, so ACM Chicago, we are part of this particular event. We're kind of one of the partners of this. So this is called Scarlet Hacks, and this is actually a hackathon. So students from all different universities, colleges can apply for teams to do a hack. So it's being held at IIT, the Kent. So IIT is actually in the other campus, not the Kent place. It's the down in the Hyde Park area or so. So if you want to know more about this, you can go to scarlethacks.com that you see there on the bottom there. Going to be on Saturday. So Saturday starts the hacking and the registration, and then the judges will do the judging of the final projects or so will be around like 12 o'clock on Sunday. So that's actually Easter Sunday. So because Easter is weekend. And actually we have one of our ACM Chicago officers, Payam, that will be one of the judges that will be there. So if you yourself or other people are interested in still, I think there's still time that you can maybe register your team there. And of course, this is a hackathon, there's always going to be pizza there, right? Throughout the entire 24-hour kind of event or whatever. So that might be a motivation factor. And then IEEE. So what do we have here? You probably saw already on the IEEE table, the flyers here. So we are doing a Region 4. So IEEE has many different regions. Region 4 is the Midwest in the US. And so Region 4, we're doing what's called a Nexus Student Leadership Conference. So we have some competitions available, awarded, and we have prizes available for those competitions, cash prizes. I believe the competition is still open. It might be still open. You can check on that. So if you go to that website there, the competitions are a paper competition. There are an ethics competition and a Shark Tank pitch competition. So for a business idea or so, and we have judges that will be judging during that event. And the actual event is on Saturday, April the 11th, at the IIT Kent School of Law. So that's just like a block away or so from Union Station. So if you're interested, the QR code is there that you can register, and also you can grab a flyer over at the IEEE Chicago table if you're interested in that. Just to kind of let you know that we will have someone actually from ARM that will be coming to give a kind of a workshop to students and faculty. So if interests you, please come to that. He wants to meet up with a lot of students and faculty to see what ARM can do, ARM opportunities for ARM. So if you know ARM is the chip manufacturer, right? In addition to you have NVIDIA, and you also have Intel, right? And AMD. So that's that one there. And The UIC business also has one coming up April 21st. This is called Shaping the Future of Agentic AI Strategy. So if you go to go.uic.edu/agentic AI, you can register for that. So that will be 3 to 6 p.m. It's co-hosted by Accenture. So Vivek Malik is the one that's going to be co-hosting this. And actually, I'm going to be one of the panel speakers on this too as well. So looking forward to that. So that's another event. And there's also our own AI event. So every year, the business school does a symposium on AI in business and society. So this year is going to be on May the 18th, so right after exam period. So if nothing else to do, come to this event on Monday from 10 a.m. to 6:30 p.m. And it will be in the Illinois rooms of Student Center East there. We have you can go to see our the AI symposium. That's the link there. You can start to register. We're going to have some keynote speakers. We have some interesting panel sessions. So I'm going to be leading 2 panels. One panel is with some industry folks talking about what are the implications, what organizations are doing in terms of responsible AI. Because we know that right now with AI systems or so, we know that it does hallucination, harm, risk, things like that. So what are some of the stuff that we can instill some responsible AI principles for that? And then also in their second panel that I'm also doing is also with academia too as well. So it's going to be a very good event. So put this down on your calendar. And finally, we're always looking for more speakers. So if you have an interesting project or a research thing that you want to, get yourself, to kind of explain it to other people in the community, it's a great way of doing so and getting feedback. So we're always looking for more speakers. So that's the contact information. Any of us will be happy to talk with you. So maybe you might be the next speaker after Patrick. And of course, we have our let's see here. Just going to show the next slide. My mouse is kind of like spinning. Okay, so actually what I'm going to show is that we have our ACM Chicago recordings of our talks. And just bear with us, we're trying to get this, all posted there. But if you go to, oops, I went a little bit too far there. Go back. There we go. So if you go to bit.ly/ACMCHI video, you will see our YouTube channel. We have, I think, videos that go all the way back to before pandemic. And then also we have videos, after too as well. We're still trying to, complete the ones that we did from last year. So this one will be made available, and so you should be able to see that on this YouTube channel. And also the other ones that you've missed, you can also watch that too as well. And of course, we don't get paid for doing this. Certainly I don't get paid for doing this. So we always look for, we're always, indebted to our volunteers, right, to help doing this, out of their own, full-time, job or so. So we really like to thank all the volunteers for doing so. And if you want to also help out, with Chicago ACM or even IEEE too as well, so not just the Chicago ACM. We have lots of different, kind of position openings. So for example, if you like to do writing, planning, as you know, Greg here is doing the video recording, but we also need people to kind of help out maybe with editing, putting things kind of together to make it more professional. Networking with future speakers. So if you want, you have other, particular speakers that you feel that could be good possible speakers for our events, please do so. And I think also it's a great way, at least for me, I feel it's a great way of bringing things back to the community. Right? So you have all this kind of knowledge and you want to contribute, right? You don't want to contribute to our society and so forth. So I think this is a great way of doing so and getting more interest in computing, right? And all the cool stuff that we have with AI. So that's it from me. So thank you very much. We have this recorded, so we will have this made available. And thank you for those that are still online. Thank you for coming. And that's it. Thank you.